Great. So welcome you all to Composable Chip and Animations Journey. For the people that don't know me, my name is Nicole Terc. I'm an Android developer at Clue. So now that you know my name, don't hesitate to say hi if you see me around. Ciao. But with this out of the way, what are we going to be talking about today? We're going to be covering three main things. We're going to be talking about animation basics. We're going to be talking about animations in Compose. And, of course, the most important part of this presentation, we're going to be talking about chip. So let's go ahead and start with some basics. And to kickstart this section of this presentation, let's go to the most important question of them all. And that is, how do you create an animation? I mean, that's why we're here, right? We need to know how. Sadly, before we answer this question, we first need to answer an even more basic question, and that is, what is an animation? If we look for this definition online, you can find something like this. An animation is illusion of movement created by a sequence of pictures or frames. I guess most of you had already heard about this definition, so if you see a sequence like this, you can probably already know that you're going to end up with an animation like the one here. Right? Easy. Now, this definition already gives us a hint of what we need to create an animation, and that is a sequence of frames. Easy peasy. We get a sequence of frames, and you get an animation, right? But we're not going to be, trying all these little images inside our apps. I mean, we could, but we're not going to do that. So in order to answer our first question better, let's take a look on how to build a sequence of frames. So how do we build a sequence of frames? Let's take a look at our original sequence here. If you look closely, you can see that there's a chip there, right? And this chip is in all the frames in there. But it's not the same chip. There are some things that are changing. We can see that the chip is going up and down. We can also see that the head of the chip is kind of, moving a little bit. And also, it looks a bit more squished at the beginning than at the end, right? And if you take even a more closer look, you can see that all these three things are changing just a little bit every time we advance one frame ahead, right? So, taking these observations into account, how do we are going to build a sequence of frames? We just need to grab these UI properties and change them a little bit every time. To formalize this knowledge, let's just write it down. So how do you build a sequence of frames? By changing a UI property sequentially between them. Nice. Now let's grab this and go back to our original definition of an animation, and let's update it a bit. Let's change that sequence part to what we already found. So what is an animation version 2.0? An animation is illusion created by the sequential change of a UI property. No surprises, right? We already kind of knew this. And this thing right there is already answering our original question. So how do we create an animation? By just sequentially changing a UI property. Like in our sequence before, see? We just change the UI properties, we create a sequence, and with a sequence, we get an animation. But how do we do this in Compose? Let's take a look at that right now. So, how do we create an animation in Compose? Believe it or not, we just need to create a sequential change of a UI property too. Easy, right? But this time we're using Compose, so we're not going to do it by hand. No. We're going to use the animation APIs. And we're going to let these ones here to handle all the sequence creation for us. Meaning that if you have a regular change like the one in here, that you have a chip passing from a big chip to a small chip, the only thing you need to do is just sprinkle some animations API magic, and ta-da! You get a sequence. And wherever there's a sequence, there's an animation. Great, no? Talk's over, you can go. But no. what are actually these magical animations APIs? Well, if you take a look at the documentation, there are a ton of them. There are different ways you can catalog them, but in this talk, to understand them better, we're going to split them in 3 categories. The ones that work with states, the ones that work with composables, and the ones that work with coroutines. And in order to take a deeper look at this and see some examples, let's start with the fun part, and let's see some chip. A small disclaimer before I start, throwing some code and stuff at you. This chip is a canvas. So anything you're going to see here, you can replicate, because, of course, it's a composable canvas. So you can do the same with a box or a text or your favorite composable. It's going to work the same. But I'm going to stick with my fluffy fella here. That's kind of the name of the presentation. So let's skip it. But going back to our serious topics, let's start with the first category of APIs. And that is the animation states APIs. What are these things? Well, the majority of the elements in this category are conformed by the animate a state functions. These functions are going to basically grab values and convert them to really, really nice changing states. Meaning that if you have this boring float there that only changes from one value to the next, if you use these functions, you're going to be able to convert this boring thing to an amazing animated float that, instead of just jumping right ahead to the target value, is going to sequence it a bit. But how do these magical functions look like? Well, they look like this. There are several of them. This is just the animated float state example, but all of them follow the same structure. They're going to be receiving a target value, and what they're going to do internally is they're basically going to grab this value inside a state. So whenever this target value changes, this state, instead of triggering right away the target value, is going to sequence that change and emit each of these steps of the sequence for the consumers. Nice. But I promised you some chip, right? So let's see an example on how to use this thing with a chip. And for that, let's create a scalable chip. So how do you create a scalable chip? Well, you, of course, start with a chip, as you do. In this case, since we're going to be making this chip scalable, we're going to be changing the modifier scale. Whenever this chip is small, we're going to pass the value 0.5. Whenever this chip is not small, we're going to pass a 1. Easy, right? Simple modifier. I hope nobody is surprised by this. So how are we going to be using these functions? We're going to ignore totally the UI, and we're only going to focus on how this scale is set. As I mentioned, these animated state functions are going to be grabbing this value. So the only thing I need to do here is, grab it. If you notice, everything remains the same. The only thing that I change is, instead of setting directly the value of the scale, I'm grabbing it in this animate float state function. Passing the target value, so whenever this value again changes, link it to my small state, this animation is going to be triggered and animated. And just by that, by changing one line in my code, I have an scalable chip. There you go. And thank you. And there are several of these functions, as I mentioned. So as easily as you create this scalable chip, you can create a groovy chip that changes color, or you can create a fading chip that appears and disappears. And you can also mix and match these things. So you can create a groovy scalable chip, or even go crazy and create a fading groovy scalable chip by the change of 3 lines. Ain't that neat? Is it, right? So to close up this section of states APIs, what is the key for this animation state APIs? You just change your vals to states. And that's it. So let's jump to the second category of our animations APIs. And let's start with some composables. Now, what are these animation composables APIs? As the name of the category already probably gave them away, these are composable functions, but these ones are going to basically handle the whole animation for us. If we want to use them, the only thing we need is an amazing UI that we want to animate, and the only step we need to do is wrap it in an amazing animation composable. And this thing right there will do all the work. If before we were thinking about how to sequence the values that we were going to consume in our UI, in this case, instead of worrying about states and alphas and whatever, we're just going to wrap it in our new composable function that is going to handle everything. Nice. But what are these amazing APIs that we have out of the box? Well, there are 4 of them, and among them already cover most of the common scenarios that you're going to encounter whenever you want to add animations to your applications. And these ones are animated visibility, that basically animates when something enters or exits the screen, animated content, that of course animates a change of content in your composables, crossfade, which is when something enters and something exits, like when you click on a tab, and a modifier, this is a sneak peek there, that basically animates a content size change, like when you click on a card. So long ago are the days of you calculating how this text was going to be in the height of the screen. You don't need to do that. You only use this modifier. But let's see an example. And for that, let's use the animated visibility composable, and let's create an appearing chip. So how do we create an appearing chip? We have a chip, as you do. You should all have chips. And following my instructions before, I just need to grab it. If you notice, the only thing that I'm passing here is a parameter with the visible value. This is going to let the composable know if the content inside it should be visible or not. Whenever this value changes, this composable is going to handle this change and is going to animate the appearance or disappearance of my chip. And just by that line, I have an appearing chip. But we already kind of have this going on for us already, right? We had that fading chip that was already kind of appearing or disappearing. So why would you like to use a composable instead of a state in this case? There are 2 reasons. The first one is that they're really easy to use. You don't need to worry about handling states. You don't need to worry about creating this alpha thingy. You only grab your UI, and that's it. You have the behavior. And the second reason is the really sweet enter and exit transitions. Yeah, I know, I'm throwing random words at you, but don't fret about them. The way you can see these transitions, you can see them as building blocks for animations that you can use and easily modify or customize the animations that you want. All of these are out of the box. This is just a sample. There are several of them, so check the documentation. And basically, you just use them, you plug and play with them, and you have a change in your animation. But how do we use them? Let's go back to our appearing chip, and let's change some things. In order for me to pass the enter and exit transitions, the only thing you need to do is pass them. There are optional parameters in that composable that receive the enter and exit transition. And these transitions are super flexible, so you can even mix and match them and just add whatever you want in there by adding a plus sign. This composable function is already going to do everything behind the screen, so you don't need to worry about who's going to start, who's going to go next. No. You just add them, and that's it. And by just adding those 2 lines, we have an appearing chip version 2.0 that has a totally different behavior than the chip before. And of course, since this is Compose, there's nothing stopping you from grabbing everything we have seen so far and create an appearing, fading, groovy, scalable chip by changing 4 lines or more. So, to finish up this section of the categories, what is the key to animation composables APIs? You just grab your UI with composables. Great. We're going fast. This is neat. Let's jump into the last category of these APIs, and that is the animation coroutines APIs. Again, what are these things? As the category name implies, these are coroutine-based animations. There are two main APIs here, which is the ones we're going to be looking at. And the first one is animate. This animate, surprisingly enough, is a coroutine, or I mean, a suspendable function. Yeah, close to it. Now, this is how it looks. It's a standalone function. So in this case, we need to pass the initial value, where our animation is going to start. We need to pass a target value, which is the value we want to reach. And since this is standalone, we also need to pass a block that it's going to be triggered in every step of the sequence that is going to be animated here. So, going back to our sequence, this animate function, the only thing it's going to do is sequence the change from the initial value we're setting to the target value we want. Great. Now, the second one we have in here is the animate2 function. How does it look? Of course, this is another suspendable function, and it looks like this. If you see, it looks quite similar to the other one, but the main difference here is that instead of receiving an initial and a target value, it's only receiving a target value and a block. You may be wondering, where is the initial state? How does this thing know from where it's going to start this animation? Well, there's a trick to this one, and that is that animate2 actually lives inside the animatable class. This animatable class is going to be the one in charge of maintaining the state, so it's going to be the one remembering from where this is going to be animated, and when calling animate2, you're going to set where does your animation wants to go. So in order to use it, first you need to create an animatable instance, and then you just call it. If it looks quite similar to the state ones, it's because this is actually the base for the other ones, but let's not dwell into details. And let's see an example of animate. And for that, let's go a bit more, adventurous, and let's create a jumping chip. So how do you create a jumping chip? Well, you have a chip, as you do, and in this case, since we want it to jump, we're going to be modifying the offset Y position. Whenever this chip is jumping, we're just going to be moving it up and down by modifying that offset Y value. But how are we going to do that? Since we're going to be using the animate API, we're basically going to ignore the UI and the way this value is set. We're not going to care about them, so we're not going to be modifying anything from our current code. And we're just going to launch a coroutine, using our trusty launch effect, of course. And inside here is where everything is going to be managed. Of course, we need to also handle the state, so whenever my chip is jumping is where we're going to add the code for the jump. And every good jump starts, going up. So that's what we do. We use animate, we pass our original value, which was 0. We pass our target value, which is 250, because chip want to jump up to 250. And whenever this value changes, I am just updating my offset Y value. And every jump up needs to go hand in hand with a jump down. So we just add that again. If you see, it's basically the same. I'm just inverting the initial and target values here. Remember that coroutines are sequential. So this jump is going to first start with a jump up, and when that finishes, it's going to go to the jump down. And just by those 4 lines of code, you have a jumping chip. But hey, this chip is kind of boring. It's just, doing one jump and that's it. What if I want this chip to be eternally jumping? Well, we're talking coroutines, so I can do whatever I want and just change the code. So in this case, if I want an even more cooler jumping chip, the only thing I need to do is change that F for a while, and there you go, an even more cooler eternally jumping chip. And of course, there's nothing stopping you from grabbing everything we have seen so far and mix it together to create a jumping, appearing, fading, groovy, scalable chip. It's starting to see a bit chaotic, don't you think? The chip is kind of disappearing behind there. It would be nice if we could, sort them up a little, sync it a bit. Well, fret not. We have another ace under our sleeve, and that is update transitions. I'm not going to explain them too deeply, so make sure to check the documentation for these ones. The only thing you need to know about these ones is they let you group animations as states and play them simultaneously. Yes, this is kind of part of the states API, but bear with me, I'm going to explain them now. So how do you actually use them? If we wanted to create an update transition for our previous example of the jumping chip, we end up with something like this. I know, it looks a bit crowded in there, but don't worry. It's just the state that I created, in this case, my jump going down or up. We have a current state that is only going to be encapsulating the current state of the jump, and then we're creating the transition. And in this section of how the transition is being created, the most important parts are the ones in here. The update transition, that basically is going to be creating a transition for us, and then these animate extension functions. These are basically kind of the same as the state ones, but instead of creating a standalone animation, these are going to create animations that are going to become the children of that transition. So you can see this transition as a sort of a box or a parent that is basically going to be handling all of these animations together. The neat thing here is that whenever the state changes, this update transition is going to trigger the animation for all the child animations in there. So they're going to be synced. Great. So if we add this update transition to our previous chip, we can pass from this chaotic jumping chip to a more organized, jumping, appearing, fading, groovy, scalable chip version 2.0. Looks better, no? I think so. But hey, we're not in the state section. We're in the coroutine section. And if you have some experience with coroutines, you're probably thinking, hey, why would you use coroutines for all of this? And the answer is yes, you can use coroutines for everything. And if you don't want to worry about transitions and the silly states or anything, you can just, migrate everything to coroutines. And just obtain the same result as before, but only coroutines. And if you want to trigger them simultaneously, you just need to coroutine and launch each of them separately in their own coroutine. And that's it, a simultaneous animated version of this jumping chip. Now, there's no need to stop in there. Now that coroutines are not changing anything in your current structure and you're adding to it, you can go wild. You can animate whatever you have in your screen. Coroutines don't care. So for example, you can change some values in a canvas and create a headbanging, jumping, appearing, fading, groovy, scalable chip. Remember that canvas are just another composable, so the values you pass, you can animate. Or, you can even go a bit more crazy and chain several animations of several components together to create a headbanging, jumping, appearing, fading, groovy, scalable chip with shadow. Great, right? But if this awesomeness is not enough for you to be convinced to use coroutines, let's see why would you like to use coroutines APIs. There are, again, two reasons. The first one is you get more control to the way your animation works. As you saw, I was able to decide where to go, when to start, everything in my animation. So if you have a really special animation, you may prefer to use coroutines instead of states. And the second reason is to handle indeterminate animations. And that means when you have an animation where you're not sure where the initial or the target value is going to be. When you encounter something like this, when using gestures. And yes, I said gestures, so we may as well go to the gesture animation, shall we? So how do you create gesture animations? Frankly, there's no real secret here. You're basically just going to use your same old gesture logic and just add some animation API calls in there. A small disclaimer, though. If you want to create some really crazy animations in there, you may want to stop using the APIs and start coding each of the frames manually. But let's not dwell into those tricky places, and let's stay to the happy pad and see an example on how to use APIs to create some gesture animations. Right? And for that, let's create a chasing chip. Now, this chasing chip is basically going to follow whatever I tap, and this chip is going to be moving around, chasing my finger. So how do we create a chasing chip? Well, you have a chip in a box, as you do, and since we're going to be moving this chip around, we're going to, again, modify the offset. This time around, we want to modify both X and Y positions because we're not going to be moving it vertically. And to hold our tap position, I'm going to be using an animate table instead of animate, sorry, so I can contain the old state in there. Now, since this chip is going to be moving around my screen, actually the one that is going to be implementing our input modifier is going to be the parent box. So that's what we do. We use our pointer input, we add our detect gestures, and in our untap lambda is where we're going to add our logic. And it looks like this. What we're doing only is basically triggering our coroutine and just updating our transition, our tap position with a new offset. The key to all of this is this animate to call. As we saw, this is going to create our sequential change for the tap, and instead of just appearing, the chip is going to animate it. And just by doing all of that, we have a chasing chip. Now, since this is basically using the normal gestures APIs and normal gestures modifiers, you can basically add animations to everything. You can create really crazy animations by using these APIs and the gestures and end up with some dragging chip, or some flying chip, or even some transforming chip. You just need a little bit of imagination and understanding of what you're doing, and you can end up with something like this. And don't worry, all these examples are in the repository, so if you're curious, you can go ahead and look how I did them. But great. To close this section, what is the key to animation coroutine APIs? You forget about anything else, and you just add some coroutines, like this cute coro chip in there. Nice. So let's sum all of this up. In order to create animations, we have 3 categories of APIs. We have the state APIs that change vals to states. We have Composables APIs that wrap our UI in composables. And we have our coroutine APIs that handle the value change with coroutines. And remember, the key thing here, and whenever you talk animations, is to create a change sequentially. And of course, there's nothing stopping you from grabbing all of these things that you already knew and create your own chasing, headbanging, jumping, appearing, fading, groovy, scalable chip with shadow. Thank you.